Dynamic Data Resolver uses a client-server architecture. In a common setup, the DDR IDA plugin runs an IDA on the analyst PC and the DDR server on a separate malware machine. In other words, the machine where you want to execute the malware sample. Obviously, there should be a machine that can easily be cleaned after the malware infection. Let's go to the malware machine and execute the test sample natively. The test sample is a multi-threading program that dynamically allocates 2 buffers and copies some strings into it. Please recognize that A cannot be bigger than 5. It is a random value between 1 and 5. We will need this later on. Let's start the DDR server and work with the tool. After it is running, we can switch over to the IDA side and work with the plugin. Let's start with the code coverage feature. If you want to gather dynamic values, you always have to run a trace over the code you are interested in. After choosing the Run Light Trace for Segment menu, DDR executes the sample. All necessary dynamic values are collected, and after the trace is done, you can highlight all executed instructions in IDA. The color of the executed instructions depends on the number of times they were executed. The more often an instruction is executed, the brighter the color. For example, light green means the instruction is only executed once, and dark yellow means it was executed many times. If the sample has anti-analysis, you can easily NOP them. Let's do this with the annoying dialog box at our test sample. After NOPing this part, we can run a trace without interruption. One of the main features of DDR is that you can resolve dynamic values in IDA after you have run a trace over the section or basic block. For example, you can now resolve values like RAX in the disassembler view. You can either get the value stored in the register or operand, or the value the register or operand is pointing to. Remember, some of these solutions only work if you have run a full trace prior. DDR also collects all API calls and tries to detect strings at runtime. Both can be displayed in an IDA chooser window. You can search both tables for certain interesting values. With a double click on a line, you are jumping straight to the location in the disassembler view. You can also manipulate the code execution flow by toggling the E flags before conditional jump instructions. As mentioned earlier, the A value in the test sample can never be larger than 5. It is a random number between 1 and 5. By toggling the SF flag, the JLE instruction thinks the comparison was greater than 5, and the program tells us A is greater than 5. Besides NOPing out of instructions and toggling E-flags, you can also skip whole functions, and a custom return value, defined by you, will be returned anytime the function is called. You can see in the output of our test sample that function 1 is not executed anymore. This function usually prints out the string, my function 1, and the value of A. In our case, this output is gone. DDR is also capable of dumping buffers at runtime. You only have to tell it where to find the size of the buffer, the address of the buffer, and at which program counter address to finally dump the buffer. DDR is then reading the size and the address of the buffer at runtime from those operands which you have marked. If you actively want to work with a sample in the x64 debugger, you can also create an x64 script that includes all of your patches and a breakpoint at the address which you have highlighted. If you'd like to use another debugger or tool, you can also create a version of the sample that is patched with an endless loop at the highlighted address. You can then attach your debugger and replace the patched bytes with the original ones provided in DDR server's output below. DDR comes with certain timeouts and configuration values that should usually work for most environments, but you can change them for special cases. For example, if you want to run a really long trace, you can extend the API timeout and/or the number of instructions DDR should trace. But keep in mind, if you increase these values, this can result in some large trace files. It is usually better to do the traces only for those code sections or basic blocks you are interested in.